Let's take a look at this problem. We got P is equal to negative 0.2 s to the third plus 4s squared plus 500. The first thing they say is find the amount S spent on advertising in thousands of dollars that maximizes the profit P. So on maximize P, that means find derivative, first derivative that is. So P prime, take the power, put it out in front. So we got negative 0.2 times 3 s, lower your power by 1, so s squared, plus 4, take your power out, put it out in front, lower your power by 1, and 500 drops away. So that gives us negative 0.6 s squared plus 8s. Now I want to set that equal to 0, so we got negative 0.6 s squared plus 8s is equal to 0. By the way, this is our P prime. We'll come back to that one. Okay, and I want to factor out. I'm just going to factor out an s. And that gives us negative 0.6 s plus 8 equal to 0. Now I'm going to set each one of those equal to 0. So I'll set s is equal to 0, and I'll set negative 0.6 s plus 8 equal to 0. So we got s is, these are our critical values we're finding now. S is equal to 0. And this one will take the negative 0.6s to the right side. So we got 8 is equal to 0.6s. Divide both sides by 0.6. Like that. And let's see what that gives us. Not very good with decimals. Second mode, exit out. 8 divided by 0.6. 13.3. And what is S? S is amount spent on advertising, thousands of dollars. Let me just take it to one decimal place. When you're talking about thousands of dollars, it may make more sense to take it to more decimal places. 13.3? Yeah. Which I could put in exact form, because obviously this is 13 to the third, but that's good enough for business purposes. We'll go with that one decimal. Okay. Got S is equal to 0. Got S is equal to 13.3. And even though it doesn't make any sense, we'll put infinity here. Can't spend infinity. We want to choose a value. Now, I didn't do a negative because, again, this is the amount spent. So negative doesn't seem to make any sense. I want to choose a test case between 0 and 13.3, like 1. And something greater than 13.3 that might be easy to work with, like 20. And we want to plug those into our derivative. So if I put 1 here, 1 squared, negative 0.6 times 1 is negative 0.6, and 8 times 1 is 8. I don't know what that is, but it's positive, so it's increasing. Now if I put 20 here, 20 may be hard to see with this, so let me go over to my calculator. I'm going to go to y equals, and I'll follow our convention that we did in class. I'll put my function on the first line, so I do negative 0.2, and I'll put an x instead of the s, but caret 3 plus 4x squared plus 500. Enter, and then on y2 I'll put my derivative, which is negative 0.6 x squared plus 8x. Okay, well, let's go to our table now. I do second graph, go to table, clean those out, and we're plugging in 20, see what we get. So do 20, enter, and remember our derivative is on y2, so it gives us a negative, which means this is decreasing. So this is indeed a max. Now what they're asking for is they say find the amount S spent on advertising in $1,000 that maximizes the profit P. So they're not asking for the profit P, they're asking us the amount, which would be 13.3 rounded one decimal place, or we could say 13 1/3 if we want to do that. And this is S equals that. That's the first thing they're asking for. Now, they're not asking us for how much the profit is. They're just saying find the amount S that maximizes the profit. Then they say find the point of diminishing returns. And the reason why I circled this is because we now need to take the second derivative. That's what gives us point of diminishing returns. So I got negative 0.6 S squared. Put your power out in front. Lower your power by 1. And 8S just becomes 8. Which, assuming I'm not very good at decimals, but assuming I get this right, let me see, negative 1.2S plus 8. Okay, now let's set that equal to 0. So I got negative 1.2S plus 8 equals 0. Take the negative 1.2S to the right side, and it becomes a positive 1.2S. Divide both sides by 1.2, and let's see what that gives us. Do a second mode to exit out. 8 divided by 1.2, enter. And we get about 6.7 if we round it. If you see the decimals, how they're going out here, and even more than that, I could do math enter. See, it's 20/3. Which is 6 2/3. But I'll go with 6.7, because that's easier to work with our table. Okay, so we got S is equal to 6.7. This is our critical value. It's only a point of diminishing returns if the concavity changes, so that's what we got to check. Clear over here is negative infinity. Clear over here is positive infinity. Though I'm not going to go into negative regions because I know it doesn't make any sense anyway, since 0 is the smallest amount, in theory. Okay, test cases. I'm going to choose S is equal to 1 and S is equal to 10. I want to plug them into our second derivative, which is right here. If I put 1 here, negative 1.2 times 1 is negative 1.2 plus 8 is positive, so it's concave up. If I put 10 in here, or even more than that, if I put 1,000, negative 1.2 times 1,000 plus 8, I don't know what it is, but it's negative, so it's concave down. So it is, the concavity does indeed change, which does mean this is a POI. And if I wanted to put the exact value, I could put the 20/3 in. And we want to plug that back into our original function. Well, on our calculator, if I press y equals, my original function was on y1. So if I just do second graph, and over here put 20 divided by 3, excuse me, and press enter, then we get 618.52. If I wanted an exact value, I could exit out, second mode, and if I press y equals, it's on y1. So I do second mode to exit out, and I could do vars, and right arrow to y vars, enter on function, and you'll see y1. Press enter on that, do a beginning parentheses, then 20 divided by 3, enter, and then math, enter. Yuck. I'm pretty sure that I'd prefer to have the decimal version of those, but 20/3 and 16,700 over 27. You can see the decimal makes a lot more sense in business, medicine, than maybe some hideous fraction like that. Telling them they're going to have 618.52 if it's in thousands or whatever profit, versus telling them they're going to have 16,700 over 27 profit. Anyway, they're asking for the point of inflection, but you can see where decimals makes more sense. And I believe that's the two things they're asking for. Point of diminishing returns. Point of inflection, which is the point of diminishing returns. Point of diminishing returns.